So we're talking about AI as finance, and as Paul already mentioned, AI is one of the first takers in at least the numbers, right? It would make sense. We're talking about money. You want to count money, so the finance, the fintech, was one of the first takers for any kind of technology, like IBM business machines, where we're talking about using that to calculate a lot of money-related issues. Later on, they were the first takers and the first benefiting parties from all kinds of machine learning. And today we have AI added. So let's talk about where does AI come in? What is this whole term? And of course, all of the opinions are mine. And the first thing that I will say is that AI is nothing new, but we'll get to that. So here's a picture of AI, the way my daughter imagines that. That's machine learning. And here's the definition of AI is where you don't have to program your computer anymore. But instead, it just picks up your data, the one that you give it, and learns from that and writes down all of the rules. Since I'm sharing the screen, I will show you a nice picture which will explain this. So let us say you're a regular programmer, okay? And as a regular programmer, you write some program. So that program gets some inputs. Here's input. And of course, the program has the outputs. That's the whole point. So now we have the outputs. What else do you want to put into this program? You want to say here is the code or the rules. So I'll call them the rules, code. Let's say we call them the rules. That's how normal programming goes, right? But if you want to think of how does AI go, that goes very similar. I'll go here, show you the AI. The only thing that we change are the rules and the output. The rules now go to the right. The outputs now go to the left. And that is AI. And to signify this, I will put it in big letters. I'll say this is AI. So AI says, I will try to find out what rules did you use, those rules here, in order to arrive at this output. So that kind of explanation became very popular recently, and you will find it everywhere, and this will be AI now. Another thing about AI is that it's called artificial intelligence, and that means that we're dealing with some kind of intelligence. So we humans are naturally intelligent, at least we like to say so, and therefore we understand what intelligence means. Well, AI is artificial, same thing. So it's very easy usually to explain what is it that the AI does, because it's trying to imitate exactly what we people do. So let's go back to the slides. Here's an example of AI, self-driving cars. And there are a few approaches here. One of them would be I give the driving booklet to the computer, the car computer, and let it learn the rules, and that won't be easy at all, because that will require for somebody, and that's not the computer, to somebody to read the book and program that book. So it's not all that far away from regular programming. That was one of the first approaches in AI. Let's extract the rules. Let's maybe ask the experts. Let's ask the financial experts and let them tell us what is a fraud attempt and what is not. So it was one of the first ones. That's not what we're talking today. That will come in. It will be important. But today, what you would do is give the computer all of the data. Tell it, this is how I drive. Let it measure. It will measure all of your driving. Let it also record the scenery, the outside, and let it then learn from your driving. And then it will imitate your driving. Okay? So anybody has a question? Was just an accident, right? Okay, that's a better definition of machine learning or AI. Here is a more practical definition. Now, before we go into this, I need to state a fact. There were many zones of interest in AI. Initially, it was in the 40s when people said, oh, AI will be smart robots. That was Isaac Asimov, right? And he was writing about robot and me, and will that robot kill me? Or all of that kind of science fiction came up, but it was, of course, science fiction at this time, and there were lots of over promises. Next period in the 80s, people said, or maybe 70s and 80s, people said, here's AI. What they really meant was, here are the rule-based system, kind of I read the booklet and I program that booklet. That wasn't AI. But this time it resulted in a big loss. People started many startups. Those startups failed. They didn't deliver on the promise of being smart AI. And there was a big winter, a frozen time for AI, when you were not allowed to even mention the word AI. You maybe don't all remember that, but there was a time when that was very bad taste. And instead of AI, people used another term. They called it machine learning. Okay, and then machine learning was okay, and it was acceptable, and it was giving you good predictions, maybe 85% precision. So that was allowed, even though you were really doing AI, you were not saying so. So here's an example. That's what I wanted to say. AI, machine learning are very close, but it also depends on the political situation today. So we today are using AI because by now it is definitely an accepted term. Good, here's one example. Let's say I want to have the computer do wonders and talk to me like a human. That's called the Turing competition. And if it can convince me that it is a human, it wins. Well, we have good candidates. We don't have a complete win. You can easily confuse a computer with his dialogue attempts. But there are quite a few pretty good automated robots, bot chats that do this. So we're on the way here. And I will use this example to formalize things a little. First of all, I will introduce all of the data. That's all of the experience of many dialogues. Secondly, I'll say that I need to give the computer a task. I need to tell it what I want it to do. And that will be task T. And finally, I need to give it a good measure of how good it is. In other words, it should evaluate itself and it should tell us I'm 85% good. And then we will choose that model as opposed to another one. So that is the formal theory. And now comes a little bit, that is how we formalize this, a little bit of linear algebra. Now, if you could do any kind of indication that you're here and tell me I had linear algebra somewhere in class or I didn't, that will be nice. Okay, so I'll say linear algebra, anyone? And you tell me if you had this linear algebra in class. Somehow indicate it in any way possible. Okay, that is usually the answer. Some, but quite a long time ago. So what I want to say here is that when you're reading a book today about AI in finance, and I'll show you one such book in a minute, then this comes up. Second chapter after the introduction is always just enough linear algebra. So first of all, I'll show you why linear algebra even comes in. Secondly, I show you that it's not that hard or not that important even. In other words, it's just a formalization of what we're saying anyway. And thirdly, I will tell you, well, all of AI is essentially linear algebra. You just do it a lot. So here's the picture. Going back to my favorite tool. And let us say we're trying to create the famous house price prediction idea. A friend comes to us and she says, I want to sell that house. How should I sell it for? So I'm asking her about the house. Tell me how many square feet, right? Square feet. And tell me how many bedrooms and how many bathrooms. And she wants to know the price. Okay, let me close that window. We're having wonderful weather here, but we also have some people who also think so. So I close that window and it's very quiet now. So, well, she says, let's say 2,000 square feet, 3, 2.5. Well, we need more data. That's exactly what we need. We need to learn from this data. So therefore, we're asking Zillow to give us all other houses, maybe in this area for comparison. And so we get more and more additional information like this. But here we do have the price. So let's say 100,000. I don't want to go into high prices at all. All right. So if you ask yourself, what is this thing? I have one number and then another number, third number, fourth number. What are those four numbers? Well, it's a row. It's a row in a spreadsheet. But if you want to think of mathematically, this is a vector. So that's a vector. I can call it vector H, maybe H1. That is about house number 1. And then there will be vector H2. That will be house number 2. And there will be H3, house number 3. So now I have formalized the problem. I have described every house with a vector. Now, if I ask you one last question, a few vectors, one on top of the other, what does that represent? What is it called? So it is called the matrix. Therefore, I can in fact represent my house with just one letter. All of the house data is just one thing vector. Now, what I'm looking for is the pricing model, and usually the pricing model is just a bunch of weights. So I'll put that word here, weights. And that means how important for the house to be big. For example, for every square foot, I'll ask for $200. That means that in the end, I'll have to take those $2,000, multiply them by the $200 weight. Then I need to ask how much is a bedroom. And the bedroom maybe is, let's say maybe 30,000. So I'll need to take number of bedrooms, 3, multiply it by 30,000, add it to the previous result. And so on. I'll keep taking the weights, multiplying it by the numbers. So what I'm doing is multiplying vectors, right? That's exactly how you multiply vectors. You take 2,000 times 200. You take 3 times 30,000. And in the end, you're essentially multiplying all of these vectors. So you can say I'm multiplying those vectors or the whole matrix of them by the weights, and what I'm getting is the price. Now that is what we're coming to. That is a very simple equation. I'll move it around the screen just to show how simple it is. And that equation gives me the complete AI model of the house price. Maybe not so smart as yet. Maybe I need a smarter model. That model is very linear. It just multiplies everything by the weights. Well, it could be that those things should interact. Maybe a very big house with very few bedrooms should be penalized. So maybe these things are not really independent, or maybe I should add some kinds of other predictors. For example, bedrooms are really important, so maybe I should also add the square of the number of bedrooms. So I should put here 9 instead of 3, and I should put 4 here instead of 2. Maybe, yes, but that all only changes the complexity of the model. The model still stays pretty easy to understand, and you can combine a few things out of this model, with the end result is that you're always taking a matrix, multiplying it by the weights. Well, that is the essence of machine learning or of AI. And that's all you really need to know about machine learning and AI. And now let's look at what we're here to talk about, the finance. So first of all, people were, as I was explaining, they were using AI technology or trying to do this for a while, and it was up and down. There were maybe 2 or even 3 winters of the AI. All these demos, and you can have those slides if you want at your request. All these demos show you how AI works today. This one is Google Assistant that talks to you, talks pretty decent. And this is a quick draw. Now, in case you have never seen it, I'll show you just a little fun exercise. That's not the right link. We'll just say Google Draw. And that's the quick draw. Okay, so what it does here is you click on this and it says draw fan. So I'm trying to draw a fan. Not sure what it looks like really. Okay, I'll give you the link. I'll give you the link. You might want to play with that. There you are. But the answer of it is that that really is already AI. And the way they do it is they give you a few choices of what you can draw. As you can see, I can draw just anything and let it guess. Instead, it says draw a mushroom. And then it has trained itself on recognizing very many mushrooms. In fact, I could probably tell you where that is. You can see here all of the things that it used for training. And as you can see, they keep collecting this. So that's one other feature of artificial intelligence. It learns. It doesn't just use your code, your ideas, but it learns on its own as well. So that would be an example of a classifier. So it gives itself a few shapes that it trains to recognize. Then it gives your data, takes your data, gives it to the algorithm so it can match the expected results to your results. And that is an essence of machine learning, supervised machine learning. And that's what teens were. Now, that's what they were, but then something changed. Here's what changed. In the 1980s and 90s, people tried to use a very smart technology called neural networks, and they always failed. It was okay for little problems, but for real big problems, regular methods like linear regression, they were still much better. Then what happened is that we got much more computing power, or really, people got much more computing power. With that, the very precise approach of neural networks, that exact approach that makes this possible. Now it came to the fore, it began to shine, and now you got extremely precise results. So now let's see. Some people say that that will actually change the whole world and pretty fast. And just like electricity changed the way we do life, so AI is changing. Not only that, Andrew Ng, who is an authority enough to listen to, he was at Google, he was at Baidu, he is a founder of Coursera. He says that any company that's worth its salt, which in his understanding is $500 million market cap, any company like that will have just one advantage over every other company, and that's the use of AI. So if that's the case, well, let's look. Well, what does AI in finance expect us to give us? And here's the book. Still, it was conceived 2-3 years ago when the word machine learning was more popular than the word AI. That's why it's called this way, but really it's the same technologies. And so that book talks about specifically where AI in finance can benefit. And I will show you also what other things happen. The book is published in a few months ago, so it's quite new, but things are going so fast that there are more interesting things in the world. So let's go. Let's look at some financial data. That would be the simulation for fraud data. That's all available. That's part of Kaggle. So Kaggle is one good platform for you to play if you're into finances. And Kaggle gives you a couple things. It gives you, first of all, a computer. You can run your code straight on the website for free. And then it also gives you a way to upload your data and store it there. So now you have a complete learning environment, a complete play environment. In fact, that book that I mentioned, it uses exclusively Kaggle for all of its explanations and all of its labs. Good. That's step number one. The financial data won't be easy to find. That will often be proprietary, sensitive, so people might use this kind of simulator. Now, the second step is to realize that finance has been doing this for quite a long time. So don't expect a revolution and don't expect people to flock to you right away. Here are the three approaches that are playing together. First of all, people were using heuristics. Let's say you're trying to find fraud detector. You're trying to find a way to detect fraudulent transactions. So as an expert, you know that if a transaction is too big, like 5 million or maybe here 200,000, then it might be fraudulent. So you're setting a limit. You're saying 200,000 or more, that's suspect fraud maybe. And the way the hackers will go at you is by figuring out your rules and changing them a little bit. You can go around human rules. That is a very simple rule. There are usually more complicated rules, and hackers are just as smart at inventing the bypasses. The next approach would be this. Let us ask the experts not just for individual rules, but for all that they do, all of the knowledge that they encompass, and will program this. That would be very similar to the approach that I showed you, the learning to drive through a book. And that too is useful. None of this goes away. You will still use the good rules to limit. You will still use the expert knowledge because that's important. That's something you don't always get in the data. And finally, the ultimate is to have a complete, what we can call end-to-end models, where you completely learn from data. You don't supply any rules of your own, but you learn from the data, and so everything will be there in play. We are interested, of course, in this last one, but we needed to mention that we're not completely alone, that there will be additional first attempts here at the top, and then we will start adding very comprehensive AI models. Now, all these models we need to measure. When we do this, we need a good measure, and that's one of the possible measures. And that measure says, first of all, I need to get the right data. So getting the right data is called finding the true positive. That's the true positive rate, and it's called precision. Precision is how much good stuff did I get. So you're looking for, let us say, fraudulent transactions. So how many of the fraudulent transactions did I get? Let's say I'm looking at 10. What's marked as fraudulent, and then I discovered that 6 of them really were fraudulent, so my precision is 60%. But there is another side of things. Did I get everything that I had to? Did I get all of the fraudulent transactions, or did I skip some completely? So this is called recall. Do I get how much gold did I leave unexamined? So now there are two measures, precision and recall. You combine them. That's what people usually do. You take precision times recall, you divide it by precision plus recall, and you got a good balance between the two. So now we did the first thing, the data. We did the scoring of the data, and let's come and let's start to look for features. So one of the features is that the timing of the transaction. That's a good feature. That's something you would come up with when you are analyzing lots of data and you're an expert, and you know that's one of the possible features. So that's great. There are other features. That's what we're doing here. Other features may come as the, let us say, transaction type. Now, technically, transaction type will lead to a little quirk, and that's it is a string, and machine learning only works with numbers. Remember, it multiplies matrices. That's all it understands. So we can encode that string as such. We're saying if the type of transaction is transfer, then that will be 1. And otherwise, it will be 0. And the other way around, if the type of transaction is cash out, then this will be 0 and this will be 1. And that way you go and prepare all of your data and you're ready. In that example, usually people first do the transfer and then they do the cash out. So the machine will learn that that combination of encoding is a suspicious combination. After that, we can use quite a lot of good existing examples. For example, credit card fraud detection. That today is working very well. the algorithms developed by Visa are amazing, and we can look at all other existing machine learning ideas that are already there and apply them to AI. Well, that is obvious. That's not something that I'd like to talk about. What I would really like is to give you something more specific to finance. So that's a diagram that shows you the terminology that we're going to use. We're going to use basically AI, which encompasses everything. That includes machine learning, that includes the deep learning, the neural networks. So just one word about the neural networks. This is a very precise tool, and it is modeling a human brain, at least to start with. So we can say that our cells in the brains, they are called neurons, they talk to each other, they get signals, they propagate signals. We can do it artificially. We can create a similar thing as neuron. Now, what scale are we talking about? That girl, she has 1 billion neurons in her brain. And our neural networks today, they have millions of neurons in our brains. So that girl is 1,000 times smarter than the neural network just because she is in possession of more neurons. And that's a tremendous power, so we shouldn't be all that nervous about AI replacing our brains as yet. But today, the millions of neurons give you a pretty good idea of what neural networks are. I will probably show you one little thing just to give you something to play with in case you don't know. So that is an example of AI that is recognizing faces. That's what Facebook has done in 2015. And it first takes features, then it combines those little features into higher level features. And that's one of the things that neural networks do. And then finally gets the faces. Okay, so we can summarize what we have said so far as this. We can say the first level in AI in finance was this: expert systems. You ask an expert to give you the rules. The next one is you get as many rules as you can, and then you let the computer to optimize that. You're saying, now I'm not just using these rules, but I'm using them in the right combination. Well, today we're right here. We're asking the computer to find the rules as well. We're saying, just get the data and find all the rules, and then find also the features. What would be the important feature? Okay. Now we're talking about finance. So to talk about finance, we need to remember that very often finance deals with time series. So there are a few different types of neural networks. Some of them deal with time series. I think it will be well if I just spell them out. And it's this. Let's do another one. So here is a neural network. And usually it's called neural network. Well, I'll show you one. Here is a neural network as given to us by Google with a neural network tool, and the neural network can find bad guys. So let's say orange guys are Buddhists and they don't mind, they're good guys, and blue guys are not Buddhists, right? And they're not so good. At least that's the point of view of the Buddhist community. So can I detect who is a good, who is not a good guy? Well, yes, here's my neural network, right? And I can run it, and it says, oh, I found it. That will be the determining line. Okay, and if you're to the left of that line, you're a good guy. To the right of that guy, you're a bad guy. In fact, that's a simple problem. It says you don't even need 4 neurons. What I have here is a brain with 4 neurons. Well, you don't need them. Oops. How did I do that? I deleted the wrong thing. Let me try to restore that. Okay, let me do it again. I said that I can do this, and I did, but now I want to remove some of the neurons, just one neuron. So a very simple brain, one decider. Even so, it will get the right answer. Okay, that's a good thing for you to play with. I'm giving you that link because if you want to play with simple neural networks, that's a good link to play with. Well, to do something more realistic, like maybe that problem. And that problem is not completely logical because that's one of the hard problems initially for neural networks. If I just try to do this and run it, then it won't get it at all. So I realize my brain is quite stupid, just one neuron. So let's add a few neurons. Will that help? Kind of, yes. It found those good guys, found those bad guys, didn't find everything. So what if I add brain power? And I'll do this by adding hidden layers. Now I have at least 2 layers of neurons, and they talk to each other. First of all, let's run. Wonderful, it found it. Secondly, let's see how real easy it does. This is x1. I take that x1 and multiply it by this 1.2. That's the weight. Remember, we started with saying that models are just a combination of weights. So here is another weight and another weight. In other words, you can see everything that it does. And that's great, and it works for simple recognizers like cat and dog recognizer. And that's the first type of neural network that is already very useful. But however, if you want to analyze images, it turns out that there are just too many pixels. Here, in this picture, we would have millions here, and millions of weights, and millions of combinations, and it's just too much to go through. So people invented a new neural network that would first go through the features, just like I showed you, little things and bigger things, and essentially filter the picture. And then after filtering, it would recognize the picture. This is called convolutional neural networks because it's doing a convolution of filtering. So that worked great, and that was a revolution in image processing, and this is what allowed Facebook to make face recognition a simple matter of standard, and so now nobody is surprised that you recognize faces. However, that was not enough. You could not predict the flow of things. You couldn't say, is the guy loading a truck or unloading a truck by just looking at individual pictures. So people created a network, a neural network that takes past as another predictor of the future so that it can now understand what's going on. It can see the sequence of the events. This is called RNN, the recurrent neural network, because you program it in a way where the past goes into the future and, as they say, impregnates the future. So the future shows us what it does. So that would be another kind of neural network. Let's get to our slide. That neural network will be able to crack this problem. Now, the first Bloomberg terminal appeared in the 1980s, I believe. That's how old the adoption of technology in the finance is. But now you can do something about this. You can use those neural networks to predict the next stock price, and that's already something great. I will intentionally avoid price prediction here because everybody is doing this. So we'll do something else. And that something else is a very useful thing in text. Of course, we all talk, we all read, we all write, and there's a lot of information there. But up until just about a year ago, people couldn't seriously analyze that. And then something happened. What happened was this revolution. I'll show you the link. That is just an, I don't know, geeky picture. What you really need is, first of all, you need to see that on the web, and then I'll explain to you what this means. This is a record of the revolution in the making. That's what's going on today with text processing. And essentially, you get more and more understanding of the text. That all started here, which for those people who are in the know is a representation of 2013 Thomas Mikolov result called word to vector. He was the first one who said, guys, your statistics doesn't work anymore because all statistical analysis of the text loses the meaning. It loses the order of words. Instead, he said, we'll train a neural network to preserve the order of words. Well, that was 2013. Now this is all 2019. So with the average of one new entry a month, you get new results, and look at who is giving you those results. It's a Google team, that's Alibaba, that's Microsoft, that's Facebook, and so on. So you see all of the big giants of AI, they are giving away their results because all of that is free. You want to use it, you click here, you get the code, and you get another very important thing, that is pre-training. So what is pre-training? Well, every time you analyze text, you rely on your knowledge of all of the books that you have read so far. And therefore, every new model that you invent will have to rely on the knowledge of all of the texts, and you would have to train it. And training is quite a lot. I'll tell you how exactly they train. So that seems like a waste of effort. And indeed, people came up with this idea. They will say, I'll give you all of the libraries that I have read, and I will give you the code. I will also give you that model. And by model, of course, we mean this, right? These weights are the model. That's what I will give you. So I'll give you that model, and you will be able to reuse even that. All you have to do is to finish it up, do one less layer. For example, let's recognize the financial implications of the text that you are reading. So how exactly do you train this model? Usually you do it like this. You feed it all of the books and you're setting it a goal. It has to have a goal. And the goal will be take out randomly some of the words, take out 15% of the words randomly, and try to restore them. If you can restore these words, then you're doing two important things. You're training yourself by yourself. You don't need any human input. That is much better than asking for humans to label and classify the documents. And then you give me those results you got so far, you get me this pre-training, and you prove the point. You can restore those words. That's usually considered intelligent. And in high school, you may have had those tests where they say, read this text paragraph, but please restore missing words. If you can do this, you probably understand what you are doing. So those guys probably understand what they're doing. And then that's what you get today. When you want to start today in AI applications and finance, then, well, you take that, you download all of the preceding results, and then you do the last layer. So let's do that. Here is a very interesting financial application of that same thing, based, as you can see, by the way, on previous works. All of the previous works are recognizably carrying this bird. What is bird? Let's go and check what bird is. Bird. Well, first of all, bird is a toy. You would probably know this. Right? That's bird. Bird here is on the right. But bird also stands, and by the way, here you have the trend that that bird is Google's entry and that Ernie is Baidu entry. And you see the trend of calling everything fun toy language. But bird stands for bidirectional transformers, BT. So I'll tell you what that means. Transformers. For that, we have to go back to our picture and add one new type of architecture. So far, I showed you, here are the architectures that will allow you to do neural network thinking. And then they will allow you to analyze images. And then they will allow to analyze sequences and find out that the latest and greatest invention and the turning point actually in text analytics are transformers. Okay, so that's a new type of neural network that's technically is capable of doing such things as training on texts. It doesn't matter all that much. The CNN, the RNN, they're still neural networks. It's just that they have special architecture that makes them more better performing. If you had all the computing power in the world, then you wouldn't even need these guys. You would do just neural networks and that would work. But there is an optimization for pictures, another one for images, and another one for texts. So we understand that part. And we understand the pictures. Now, if we go back to our slides, now we understand this. So if you take all of the financial text, apply the BERT idea, pre-train your model on the SEC filings, then the problem you're solving here is this. You can read all of the 10K reports. The 10K reports, of course, is a bureaucratic jiggle jungle, right? Or lots of vague statements, which are made vague intentionally. For example, like, I don't tell you that I'm predicting the future, so I'm relying on my best estimate. It's kind of, I'm saying it in a positive way that what I'm saying is not exactly true. But if you can understand such things, then you can glean a lot of financial information from the text, and up until now that was nowhere near possible. And today it's quite doable, and that's how they did it. They took, of course, BERT as a general language analyzer. They added a layer that works for understanding financial texts and ambiguities. That's the diagram. And by now you can automatically estimate what other companies say. So far, I showed you a few things that are here in AI for finance. The first one was reusing the existing stuff, reusing the existing image recognition, reusing the existing prediction. And now this is something quite new. You can reuse and apply text. So that pretty much covers that. There is an interesting AI development that works great for other tasks, and that's called the GAN. GAN stands for Generative Adversarial Network. And the idea here is that you have two networks playing with each other. One is trying to create a fake document, and the other one is trying to detect it. And they become quite experts because they keep doing this to each other. So the discriminator becomes smarter and smarter, and the faker becomes smarter and smarter. So that's one more approach. With that much power, you can get quite a lot today. And so now comes back what are we doing? We're dealing with money, we're dealing very often with humans. And that means that we have to deal with a lot of legal aspects, privacy and fairness. And that's different from all other things. It's okay to recognize faces, and the fairness doesn't ever come up. There is no question of discrimination. But for money, there are lots of regulations. So these are the issues that come up. The issues are that if you're training machine learning or AI based on some data, then you might just as well ask humans, and the humans, if they're biased, your model will be biased. If your model reflects the current situation, for example, let's say that women traditionally earn less than men, well, your machine, your discriminating machine, because in fact what AI is in this case is just a discriminating machine, will learn to discriminate against women, right? So these are all of the important issues that you'll have to deal with, and it will be unique and hard. Why? Because if you're building a discriminating machine and then you're doing the anti-discrimination laws, then you're internally fighting with yourself. That's not unsurmountable, that's doable. And the way to do it is you first of all go technically against the rules and you eliminate bias. For example, let us say a certain area is traditionally populated by certain people who are a minority and underprivileged minority. So you don't put the race in there in your predictors. That won't be unfair against the law. Well, if you put the zip code, that's very close, but at least they cannot get you on the formal side of things. Well, but they can still argue that your program is prejudiced because it uses the zip code, and zip code correlates very highly to the race, and that's prejudiced. So what you do then is you eliminate even these predictors, but you don't want to lose precision altogether. And so that book, by the way, gives you one idea of how you can combine the fairness and precision. So that's one of the things. The other things is the legal perspective. And here you understand that you're doing with legal language. So it has a very specific, even if not exactly making sense definitions of what is discrimination. It results in either disparate treatment or disparate impact. And then they also have the rule. If you, as an attacking side, can prove that it seems like my client is underprivileged and 80% of people in my group who are my clients, they are all getting refusals, then, well, that's the beginning of the lawsuit. However, it's not all that easy. Just recently in New York, they had the evaluation of firefighters. And so 19 white guys passed the evaluation and one Mexican passed the evaluation, and none of the black guys passed the evaluation. So, well, doesn't look good on either side. And therefore, the city just annulled that. They said, well, forget that. We're not going with that. Well, now the guys who were okay according to that evaluation, they sued back. They said that, is that fair? So that's all kinds of things that you get, and that's all kinds of legal. Here is a possible solution. That's a diagram where you're trying to balance what's legal, what is the effect of the race, what's the effect of the gender, and that is your quality of model. So your accuracy goes slightly down as you keep playing with different numbers, and it reaches some good compromise where you're taking laws into account, but you're not losing too much in the process. So that's one of the possible things. Now, the rest of the slides just goes through the terms. Terms, you probably know. I'm not going to do that. I included them because we need that. And if you're getting the slide deck, you'll be interested in this. But I'm not going to go through those terms. There's a standard machine learning terms. I probably just want to mention one thing at the very end. Here are all the tools that you could use. Here is one important thing, and that is there special hardware for machine learning and for AI? Well, it turns out that yes. We all are using CPUs, that's our laptops, but we know that there is a much faster performing GPU. So you can buy yourself a GPU as an accelerator, or you can go to a website like Kaggle, which will allow you to run on this GPU, and by the way, for free. But the best performance you can get if you build a computer specifically for initial computations or a computer specifically for machine learning, which, as I mentioned, is all about linear algebra. So if your computer could just multiply matrices as one operation, that would be a win. Well, here's that win. This is called TensorFlow Processing Unit or Tensor Processing Unit, because it comes from Google, and Google's favorite library and actual world's favorite library is TensorFlow. So that thing can implement TensorFlow operations or AI operations, matrix multiplication. And then that's just the processing unit. Then if you put it together, that becomes a computer. And that computer is available to you as of March 2018 in the Google Cloud. So that's where most of this big training that I was mentioning, that's where it goes. For example, BERT was trained for 4 days non-stop on 16 such machines. Okay, and then others, of course, are not standing still. They're imitating it. Amazon has an interesting way of doing gate arrays to achieve the same result. So every cloud has some answer to this. That would be the questions that I would ask, but really I don't want to ask you the questions. Rather, I want to stop right here and I want you to ask me questions if there are any. No, I don't see. Well, okay. Question, great question. What is the greatest challenge for AI in finance? Well, I think you could see by now that the technology by itself is not a challenge. Quants are all used working with technology. So that's not something like I'm teaching the farmer how to use a computer. And the farmer probably can teach me a few things. It's the legal aspect. You will see that you're building a discrimination machine which are bound by non-discrimination laws. And nothing is obvious here. So that's what I would say is probably the most challenge. But of course, all that technology, even though it's not surprising, and it's not that people don't want to use it, but it will be fun to implement it. You need to follow the latest. I showed you all the progress that people are making with text analytics. So if you are 1% smarter than a competitor, then you probably get much more than just 1%, because today the precision is in the 90% range, 90 to 95. So 1% of more precision will mean 10% more profit to you, or maybe more. So these are the challenge. Question, is this true? One of the limitations of machine learning is that it relies on the historical data, and therefore it may be unreliable. Conscious, unconscious bias. That's totally true. And for that, you need to always be aware and build your additional tools. The additional tools will look for bias. They say, okay, people think that this is shiny metallic things that are very smart and objective. And as you can see, it's completely untrue. They're not objective, they just encoding your previous biases. So that's where you need to come with a technology solution to the technology problem. Is that an answer that you were looking for? Yeah, all right, thank you.